Now that we have talked on addition law, subtraction law, and power law, there are two more laws which we'll just combine as one in this video. Now, before we continue, let's take a quick recap on addition law, subtraction law, and power law. Addition law states that log pq to base b is equal to log p to base b plus log q to base b. Likewise, subtraction law says log p divided by q to base b is equal to log b to base b minus log q to base b. And the power law simply says that log p raised to the power of n to base b is equal to n log p to base b. Now, the additional laws we will be taking a look at in this place is when we have, the first one is when we have the same base, the same number, and the same base, and this will be equal to 1. So I can rewrite this and change color. This is a red. So how do we arrive at this? Now let's recall again that in this form, logarithm form, okay, now recall that b or p is equals to b raised to power x, likewise q is equals to b raised to power y. Now what if we just have b, it is b raised to the power what? 1. So b is b raised to the power of 1. Therefore, if we'll convert this itself, okay, this in itself to a logarithm format, we will have that log b to base b is equal to 1. So everything is dependent on conversion from index form to logarithm form. So when we have the same base and the same number, it is equal to 1. So let's take quick examples on that. So this is the first additional law. Same base, same power, or same base, same number will be equal to 1. So let's take an example. So remember that in our last video, we recall though we have log 81 to base 3, and our answer is 4 log 3 to base 3. Now this can be written as 4 times log 3 to base 3. Now this log 3 to base 3 is the same thing as 1, because if you apply the principle here, that's when we have the same base and the same number, the result is 1. So this will be 4 times 1, and which is equals to 4. So log 81 to base 3 is equal to 4. Now it's simple. So if you have log 81 to base 3 is equals to 4, in index form, this will result into 3 raised to the power of 4 is equal to 81. Let's take another example. So also in our subtraction law, we came across this example that when we want to resolve log 8 to base 2 minus log 4 to base 2, yeah, and if we apply the subtraction law here, we will have log 8 over 4 to base 2. Okay, so 8 over 4, and this will give us log 2 to base 2. Now log 2 to base 2, because it has the same base and it also has the same number, this will be equal to 1. Let's take another way to solve this now. Log 8 to base 2 can be written as log 2 raised to power 3 to base 2. Log 4 to base 2 can be written as 2 raised to power 2 to base 2. Okay, now in itself, this will come to the back, likewise this, so we'll have 3, okay, 3 log 2 to base 2 minus 2 log 2 to base 2. Now log 2 to base 2 in this case is 1. Likewise, log 2 to base 2 in this case is also 1. So it will be 3 multiplied by 1 minus 2 multiplied by 1. And when it is solved, will resolve into 1. So it's not unilateral. We can go through the same question in multiple ways and we'll arrive at the same answer. So we have talked on the first law, which is same base, same number. That's log b to base b is equals to 1. Now let's take another one, and the last one says log b or log 1 to base b is equal to 0. Now this says that any number, if the number is 1, irrespective of the base, the answer will be 0. So we recall again our interface between index form and logarithm form that says x to the power n is equals to y, and likewise log y to base x is equal to n. So while proving, we are having b raised to the power x is equals to p, and likewise q to be equals to p raised to the power of y. Now if we have b raised to the power of 0, according to the law of index, anything raised to the power of 0 is equal to 1. So if b raised to the power of 0, given that b raised to the power of 0 is equal to 1, if we convert this in itself to logarithm form using this conversion now, we will arrive that log of 1 to base b is equal to 0. So everything is based on how we can relate index form to logarithm form. So if b raised to the power of 0 is 1, then log of 1 to any base b is equal to 0. Now let's take two questions regarding that. So let's look at, if we recall from our addition law, where we had log 16 to base 2, and we resolve 16 in itself because 16 can be written as 16 multiplied by 1. It can also be written as 8 multiplied by 2. It can also be written as 4 multiplied by 4. So if we use 16 is equals to 16 multiplied by 1, we will have it, applying the addition law, we'll have 16 to base 2 plus log 2 or log 1 to base 2. Now anything log 1 irrespective of the base is equal to 0. So we can rewrite this as log 16 to base 2 is equals to log 16 to base 2 plus 0. Therefore log 16 to base 2 is the same thing as log 16 in itself to what? To base 2. Yeah, so that's improved. So let's take another example. Again, in our subtraction law, where we have log 8 to base 2, we recall that 8 can be written as 8 divided by 1. 8 can also be written as 16 divided by 2. 8 can also be written as 24 divided by 3, as the case may be. So when we apply the first principle, we have that this will give us log 8 to base 2 minus log 1 to base 2. Okay, now log of 1 irrespective of the base is 0, so this will give us log 2 to base 8 minus 0, and at the end we'll see that these two correlate to each other, and then we arrive at log 8 to base 2 is equal to log 8 to base 2. Now that we have 5 laws, or 3 main laws, 2 additional laws in logarithm, we have log of a number 1 is equals to 0, log of the same base, the same number is equals to 1, and we have the main law, the addition law, the subtraction law, and the power law. In our next video, we'll be combining all these laws to simplify the function of logarithm.